Welcome to my channel V Concepts CHM. In this video, we are going to study about work as a path dependent function. Work as a path dependent function. A system can be taken from state A to B by many ways, as it is shown in this diagram. This is the state A with the coordinates P1, V1, and this is state B with the coordinates P2, V2. P1 and V1 represents the pressure and volume of state A, and P2 and V2 represents the pressure and volume that of state B. So the system is going from the state A to state B through different ways. You can take the system from state A to state B along this path AB, or along this path ACB, or the third path can be considered as ADB. We will first consider the first path. Let us start from point A. The pressure is continuously decreased from P1 to P2 along this curve AB. So first we are considering this path, first path AB. The pressure is decreasing from P1 to P2 and the volume is increasing. You can see from V1 to V2 as you go from A to B. So we will write down the work done by the system, which will denote as W1 is equal to, we will have to integrate integration of P dV with the limits from V1 to V2. Now this work done is, or it can be written as equivalent to the area under this curve AB. So what is that area? This is this area under the curve AB, that will be A, B, F, E. Now we will consider the second path. We'll start again from point A. The volume V1 is kept constant and the system is going from this state A to D. As the volume is constant, no work is done here. Then the pressure is here the pressure is decreasing from P1 to P2. Then the pressure P2 is kept constant and taken from this state D to state B. So here the pressure is remaining constant. Here the volume is remaining constant, so work done is 0. Here the pressure is kept constant at P2. Volume is changing from V1 to V2. So we'll write down the work done, which will denote as W2. This is, we are considering the work done along the path dB, which will be equal to P2 into V2 minus V1, and the area under this curve ADB we will write down as DBF E. Now again we will see for the third path. We will again start from point A. So that is this path here. The pressure is kept constant. P1 is kept constant when you go from state A to state C. And then here along CB, the volume V2 is kept constant. So here along this path, the work done is 0 as the volume is remaining constant. So we will write down the work done in this process for this part ACB as W3 is equal to P1 into V2 minus V1. And the area under the curve we'll write down as A, C, F, E. So if you now compare from the 3 points for the 3 different paths, we have got W1, W2, W3. We have written down it in the terms of area, and we can see that they are all different. So W1 is not equal to W2 and it is also not equal to W3. All the work done, they are not equal. So from this we can conclude that the work done depends on the path of the process. For each path, the work done is different. So the work done depends on the path of the process when the system goes from one thermodynamic state to another. Thank you for watching this video.